Using a grounding clamp on a cold water line to create a mechanical ground for a 2-wire outlet poses no significant safety issues and is a common and acceptable practice. Firstly, improved safety is achieved because the grounding clamp provides a path for electrical current to flow in the event of a fault, protecting against electrical shocks. Secondly, there is compliance with electrical codes because most electrical codes require mechanical grounding for outlets in certain areas, such as bathrooms and kitchens. Several safety considerations must be observed when installing a grounding clamp. Firstly, ensure proper installation. The grounding clamp must be securely attached to the cold water line using the appropriate hardware. Secondly, use a copper clamp. Grounding clamps made of copper are recommended for best conductivity and longevity. Thirdly, avoid contact with hot water lines. Do not attach the grounding clamp to a hot water line, as it may create a potential fire hazard. Fourthly, inspect regularly. Periodically inspect the grounding clamp to ensure it is still properly attached and not corroded. It is important to ensure that the cold water line is connected to a continuous metal piping system that extends to the main water supply. If the cold water line is made of plastic or another non-conductive material, a supplemental grounding method may be required. In residential electrical systems, grounding ensures safety by providing a low-resistance path for fault currents to return to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. Grounding to a metallic cold water pipe system is an acceptable method because it typically provides a continuous, conductive path to the earth. However, it's crucial to verify the continuity of the piping and ensure that it's not interrupted by non-conductive couplings or sections. Bonding is another essential concept in electrical safety. Bonding involves connecting all metallic parts of an electrical system, such as metal enclosures, conduit, and equipment, to create an electrically conductive path. This path ensures that all metallic parts are at the same potential, reducing the risk of electrical shock. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety of people and property. Some key NEC sections related to grounding include Article 250.4, which covers general requirements for grounding and bonding, Article 250.50, which addresses grounding electrode systems, and Article 250.104, which outlines bonding of piping systems and exposed structural metal. When using a cold water pipe as a grounding electrode, it's important to comply with NEC requirements. This includes using the correct size of grounding electrode conductor, properly bonding the water pipe to the grounding electrode system, and ensuring that the water pipe is electrically continuous. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Table 250.66 in the NEC provides guidance on the minimum size of grounding electrode conductors based on the size of the service entrance conductors. For example, if the service entrance conductors are 2/0 American wire gauge or AUG copper, the minimum size of the grounding electrode conductor is 6 AWG copper. When installing a grounding clamp on a cold water pipe, it's important to use a clamp that is listed for grounding purposes and is compatible with the pipe material. Copper clamps are generally recommended for copper pipes, while bronze or stainless steel clamps may be used for other pipe materials. The clamp should be securely attached to the pipe, making good electrical contact. The location of the grounding clamp on the cold water pipe is also important. The clamp should be located as close as possible to the point where the water pipe enters the building and should be accessible for inspection and maintenance. In addition to grounding to a cold water pipe, other grounding electrodes may be required, such as ground rods or ground rings. A ground rod is a metal rod that is driven into the earth to provide a grounding connection. A ground ring is a continuous loop of bare copper wire that is buried in the earth around the perimeter of a building. The NEC requires that all grounding electrodes be bonded together to form a grounding electrode system. This ensures that all grounding electrodes are at the same potential, reducing the risk of electrical shock. The bonding conductor should be sized according to Table 250.66 in the NEC. When working with electrical systems, it's important to follow safe work practices. This includes energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you're not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work. An electrician has the training and experience to safely install and maintain electrical systems. Ground fault circuit interrupters, or GFCIs, are an important safety device that can help protect against electrical shock. A GFCI is a device that monitors the current flowing in a circuit and quickly shuts off the power if it detects a ground fault. GFCIs are required in certain areas of the home, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or ARFCIs, are another type of safety device that can help prevent electrical fires. An ARFCI is a device that detects arc faults, which are dangerous electrical conditions that can cause fires. ARFCIs are required in many areas of the home, such as bedrooms and living rooms. Electrical panels should be properly labeled to indicate the circuits that they serve. This can help make it easier to identify and troubleshoot electrical problems. The panel should also be kept clean and free of obstructions. Regular electrical inspections can help identify potential problems before they become serious. An electrician can inspect your electrical system to ensure that it's safe and up to code. Electrical safety is important for protecting people and property. By following safe work practices and complying with electrical codes, you can help reduce the risk of electrical shock and fire. In addition to grounding, bonding, and the use of GFCIs and ARFCIs, surge protection is another important aspect of electrical safety. Surge protection devices, or SPDs, protect electrical equipment from voltage spikes, which can damage or destroy sensitive electronics. SPD are typically installed at the service entrance to a building and can also be installed at individual outlets. The NEC provides requirements for surge protection in Article 230.67. Proper wiring practices are essential for electrical safety. Wires should be properly sized for the load they are carrying and should be installed in accordance with the NEC. Connections should be tight and secure to prevent overheating and arcing. Extension cords should be used only temporarily and should not be overloaded. Damaged extension cords should be replaced immediately. Lighting fixtures should be properly installed and maintained. Bulbs should be the correct wattage for the fixture, and fixtures should be kept clean and free of dust. Smoke detectors are an important safety device that can help save lives in the event of a fire. Smoke detectors should be installed on every level of the home and should be tested regularly. Batteries should be replaced at least once a year. Carbon monoxide detectors are another important safety device that can help protect against carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas and should be tested regularly. Appliances should be properly installed and maintained. Follow the manufacturer's instructions for installation and use. Regularly inspect appliances for damage and have them repaired by a qualified technician if necessary. The electrical system in a home or building is a complex and potentially dangerous system. It's important to understand the basics of electrical safety and to take precautions to protect yourself and your property. If you have any questions about electrical safety, consult a qualified electrician. They can provide expert advice and help ensure that your electrical system is safe and up to code. When connecting a grounding electrode conductor to a metallic water pipe, it's crucial to use a listed grounding clamp or fitting that is suitable for the pipe material and the size of the grounding electrode conductor. The connection should be made on the street side of the water meter or any insulating fittings to ensure that the entire metallic water piping system is effectively grounded. If the water meter or any other component in the water piping system is likely to be removed or replaced, a bonding jumper should be installed around it to maintain the continuity of the grounding path. The bonding jumper should be sized in accordance with the NEC requirements. In some cases, the local electrical codes may require the use of a supplemental grounding electrode, such as a ground rod or ground plate, in addition to the metallic water pipe. This is often required when the water pipe is not reliably grounded or when the local soil conditions are not conducive to effective grounding. When installing a ground rod, it should be driven into the earth to a depth of at least 8 feet and should be located at least 6 feet away from any other underground metallic structures such as gas pipes or underground electrical cables. The top of the ground rod should be flush with or below the ground level to prevent it from being damaged or creating a tripping hazard. Ground plates are typically used in areas where it is difficult to drive a ground rod, such as in rocky or paved areas. The ground plate should be buried at least 30 inches below the surface of the earth and should be located at least 6 feet away from any other underground metallic structures. When connecting the grounding electrode conductor to a ground rod or ground plate, it's crucial to use a listed grounding clamp or fitting that is suitable for the materials being connected. The connection should be made in a manner that ensures a permanent and reliable electrical connection. The grounding electrode conductor should be protected from physical damage by enclosing it in conduit or other suitable protective material. The conduit should be securely fastened to the wall or other supporting structure. The grounding electrode system should be inspected periodically to ensure that it is in good condition and that all connections are tight and corrosion-free. Any damaged or corroded components should be replaced immediately. If you are unsure about any aspect of grounding or bonding, it's always best to consult with a qualified electrician. They can assess your specific situation and provide recommendations for ensuring that your electrical system is safe and up to code. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirement. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and is also available online through various subscription services. Many local jurisdictions also have their own electrical codes that may be more stringent than the NEC. It's important to check with your local building department to determine the applicable electrical codes in your area. Proper grounding and bonding are essential for electrical safety. By following the requirements of the NEC and local electrical codes, you can help protect yourself and your property from the hazards of electricity. The goal of grounding is to minimize the voltage between electrical equipment and ground, thereby reducing the risk of electric shock. This is achieved by providing a low impedance path for fault currents to flow back to the source, which in turn causes the overcurrent protection device, such as a circuit breaker or fuse, to trip and to energize the circuit. Bonding, on the other hand, is the process of connecting all metallic parts of an electrical system together to create an electrically conductive path. This path ensures that all metallic parts are at the same potential, which reduces the risk of electric shock if someone comes into contact with two different metallic parts that are at different potentials. Grounding and bonding work together to provide a comprehensive electrical safety system. Grounding provides a path for fault currents to flow back to the source, while bonding ensures that all metallic parts are at the same potential. Together, these two concepts help to minimize the risk of electric shock and fire. In addition to grounding and bonding, it's also important to use ground fault circuit interrupters, or GFCIs, in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. A GFCI is a device that monitors the current flowing in a circuit and quickly shuts off the power if it detects a ground fault. A ground fault occurs when current flows through an unintended path, such as through a person's body. GFCIs are designed to trip quickly enough to prevent serious injury or death from electric shock. Arc fault circuit interrupters, or ARFCIs, are another type of safety device that can help prevent electrical fires. An ARFCI is a device that detects arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when there is a break or weak spot in a wire, or when there is a loose connection. ARFCIs are designed to trip quickly enough to prevent a fire from starting. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges, which can damage or destroy sensitive electronics. Voltage surges can be caused by lightning strikes, power outages, or other disturbances in the electrical grid. SPD are designed to divert excess voltage away from electrical equipment, protecting it from damage. Proper wiring practices are essential for electrical safety. Wires should be properly sized for the load they are carrying and should be installed in accordance with the NEC. Connections should be tight and secure to prevent overheating and arcing. Extension cords should be used only temporarily and should not be overloaded. Damaged extension cords should be replaced immediately. Lighting fixtures should be properly installed and maintained. Bulbs should be the correct wattage for the fixture, and fixtures should be kept clean and free of dust. Smoke detectors are an important safety device that can help save lives in the event of a fire. Smoke detectors should be installed on every level of the home and should be tested regularly. Batteries should be replaced at least once a year. Carbon monoxide detectors are another important safety device that can help protect against carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas and should be tested regularly. Appliances should be properly installed and maintained. Follow the manufacturer's instructions for installation and use. Regularly inspect appliances for damage and have them repaired by a qualified technician if necessary. The electrical system in a home or building is a complex and potentially dangerous system. It's important to understand the basics of electrical safety and to take precautions to protect yourself and your property.